Hello student, welcome to your chemistry lab. Today I am starting daily practice paper DPP 012 and answer and solution of DPP 007 in this video. Today daily question paper coming from equilibrium chapter. Now we are see now 2020 question paper. Two questions are coming from equilibrium chapter. One was coming from acid base concept, and that is the identify basic in nature of the salt. You check the question number 28 in code X6. And other question was coming from solubility product of salt. You check the question number 45 in code X6. So I will be guessing for 2021 KP-KC related question and last circular principle related to chemical kinetics type question. That is, reaction was forward or backward or equilibrium hold. This type are question important, very important. So pH calculation and also pH calculation, simple pH calculation, acid base salt pH calculation and hydrolysis of salt of pH calculation, and buffer solution and pH calculation of buffer solution, and also important pH calculation for redox reaction, that is acid base titration type question are important from this chapter. So read carefully. You have to practice and practice with MCQ with topic wise. So let's start the DPP. You watching the whiteboard now. Now, answer and solution of DPP 007. Let's start. Welcome to your chemistry lab. Now start answer and solution of DPP 007. Published date 04/06/2021. First question. Question number 1. Photon having energy equivalent to binding energy of fourth state of helium ion are used the metal surface of work function 1.4 eV. If electron are further accelerated through the potential difference of 4V, then the minimum value of de Broglie wavelength associated with the electron is. Options are below. Answer is C. Here energy given to the electron is 13.6 by 4 square into 2 square. That is the formula is 13.6 into Z square by N square. Here gives the value 3.4 eV. Work function equals to 1.4 eV and additional energy supplied due to acceleration is 4 eV. Net resultant kinetic energy 3.4 minus 1.4 plus 4 equals to 6 eV. And de Broglie wavelength formula of de Broglie wavelength lambda equals to h by p, and p is the momentum and it convert to kinetic energy, so h by root over 2 kinetic energy into m, or kinetic energy equals to q into v. So then given formula is, and so value is 5 Armstrong. So it is clear now. And next question 2. If the nitrogen atom had electronic configuration is 1s7, it would be having energy lower than that of normal ground state electronic configuration 1s2 2s2 2p3, because the electron would be closer to the nucleus, yet 1s7 is not observed because it violates Heisenberg uncertainty principle, Hund's rule, Pauli exclusion principle, Bohr postulate of stationary orbit, and its answer is C. Pauli exclusion principle. According to Pauli exclusion principle, an orbital can accumulate maximum 2 electrons, hence the Pauli exclusion principle violates. And next 3. The m value for an electron in an atom is equal to the number of m value for L equals to 1, and electron may be present 3d x square minus y square, 5m x y z, and 2p x and 3s. And answer is B. Here number of magnetic quantum number m equals to 12 plus 1, so number of m value for L equals to 1 means ml equals to 3, because minus L to plus L, then minus 1 0 plus 1, then value of magnetic quantum number is 3. This value is possible for m in case of m and higher subcell only. So it is clear now. And next question 4. The frequency of a certain line of Lyman series of the atomic spectrum of hydrogen satisfies the following conditions. It is the sum of the frequency of another Lyman or Blammer line, and second point, it is the sum of the frequency of a certain line and Blammer line and Passon line, and third point, it is the sum of the frequency of Lyman and Passon line but not bracket line. To which transition does frequency correspond? Option A, n2 equals to 3 to n1 equals to 1. Option B, n2 equals to 3 to n1 equals to 2. Option C, n2 equals to 2 n1 equals to 1. Option D, n2 equals to 4 and n1 equals to 1. So answer is D. Back to question. D equals to n2 equals to 4 to n1 equals to 1, and so the data indicates the value of transition is only possible with Lyman and Blammer Passon series. That means transition to fourth orbit is not possible, which means the transition from fourth orbits occur. So next question 5. Find the product of multiplication of number of electron correspond to n plus L equals to 3 and L equals to 2 in CU. Options are given and answer is A. Electronic configuration given 1s2 2s2 2p6 3s2 3p6 4s1 3d10. N plus L equals to 3 means 2p6 and 3s orbital. L equals to 2 means 3d10 orbital. So N plus L equals to 3 equals to 8 electron. L equals to 2 means 10 electron, and then total electron is 8 into 10 equals to 80. So it is clear now. And next question 6. the quantum number of most energetic electron in argon atom when it is in first excited state is option R. Answer is C. The electronic configuration of argon atom is 1s2, 2s2, 2p6, 3s2, 3p6. In its first excitation state, the electron from 3p will occur unpaired and shift to 4s, and where its quantum number will be 400 plus minus half. So it is clear now. And next question 7. Which of the following orbital is associated with the angular nodes? Option A S orbital, B P orbital, C D orbital, D F orbital. So answer is A. Angular nodes only associate the directional orbital. Next question 8. The number of unpaired electron in Mn4 positive Z equals to 25 is option are given, and answer is D. Mn4 positive 21 electron equals to argon 3d3 contain 3 unpaired electrons. And next question 9. Statement 1. Limiting line in the Blamar series has a wavelength of 36.4 nanometer, and statement 2. Limiting line is obtained for a jumping of electron from n equals to infinity to n equals to 2 for Blamar series. Option are given, and answer is A. And back to question 1 is true, statement 2 is true. Statement 2 is the correct explanation for statement 1. So it is clear now. And next question 10. If the quantum number are defined as n equals to 1, 2, 3, L equals to 0, 1, 2, n minus 1, m equals to minus L to plus L, how many electron could be fitted in first cell? Option are given, and answer is D. N equals to number of L value possible for first cell equals 3, that is 0, 1, 2. So the total possible number of m value are 9, 1 plus 3 plus 5, and number of m value for given L equals to 12 plus 1. So the number of electron can be filled 2 into n equals to 18 electrons. So it is clear now, and thank you everyone. Thank you everyone. I come back with daily practice paper DPP 013, and so thank you everyone.